Okay, so hi Mr. Day, I'm Aisha,
I'm Christina.
and we're doing the energy stored in the spring.
Spring energy.
Yeah, the spring energy screencast. So
Yeah.
explain. Christina's gonna explain the equation.
Okay. So our results were kind of weird, so we used around the same data that you did. So yeah. Okay. So basically here we plotted we put in torque measurements along with, well, hold on, go back. We have the angle in degrees, the torque in newtons, and yeah. Also, in order to find, do you want to go to the
Yeah.
side? Thanks.
Arc.
So for the last, to find arc distance, which is also S in meters, we plugged in a formula which you gave us in class, which is angle times pi over 180 times 0.5875. So that's how we got the arc length, and when we plotted, we got this graph. We took out these 2 points, we stripped them out because they were messing with our graph, and they would have, So we took them out so we'd have a more clear perception of our graph. What else? Oh yeah, okay. So our slope is 26.75 newtons over meters, meaning for every meter it's stretched, the force is 26.75 newtons. And also the force that for the y-intercept. This is the amount of force that the spring has to begin with. So 2.684 newtons. And so, what else I forgot about?
Equation for torque.
Oh yeah, the equation for torque. So the equation for torque is ms plus b, which is what you gave us in class to do. So when you plug it in, you have 26.75 newtons over 1 meter times the arc distance plus the y-intercept, which is 2.684 newtons. And yeah, that's the equation for torque.
Okay, and then when we take the area under this graph, we get the total energy in the spring. And so it's a trapezoid. So what we did is that we first found the arc distance, and we did that by using the estimates that you gave us, because our the video or our data for our video was kind of strange. So we just did like you showed us. We did 3 over 4 times pi, which was your estimate, and then we multiplied that by the measure of the radial arm, which is also the estimate from your example, and then that gave us 0.23. And then when we plugged 0.23 into the equation for torque, we just did 26.75 times 0.23 plus 2.684. We got 8.83, which is so like that would be 8.83, which would it would be the height, so it would be like all the way up here. So it would be one base, sorry, of the trapezoid. And so our first base for the trapezoid is this length, which is 2.684, because that's the y-intercept. And our second one would be it would be like all the way up here, because it's like 8 something.
Yeah.
So it would be somewhere here, and that would be
8.9. No, you got 8.3.
8.83. So that would be the second height, and so we just then use the formula for area of a trapezoid, and that's 1/2 times the sum of the two bases, which is 2.684 plus 8.83 times the height, which is this. Which is this distance here, which is 0.23, and we got 1.324 joules, which is the area under this graph, and which gives us the amount of energy stored in the spring. And that's it for the screencast.